to the first of this year's Gibbons lecture series. My name's John Hosking and I'm the Dean of Science here at the University of Auckland. It's my very great pleasure to welcome you here this evening. The Gibbons lectures are an annual series of talks hosted by the Department of Computer Science in association with ITPNZ and the Auckland ICT Graduate School. The goal of each lecture is to describe detailed developments in a particular research area to a general but technical audience, from computer science students at all levels to IT practitioners and other departments and outside the university. I particularly welcome the large number of ITPNZ people here tonight. The Gibbons lectures are named in memory of Peter Gibbons, a former head of the computer science department and a good friend and mentor to many, including myself. This year's theme is Robots Everywhere, Robotics in Industry and at Home, a topic which has been receiving much attention in the popular press, with robots offering the potential to augment human activity and undertake increasingly more complex tasks, but with corresponding fears of job losses and worse. Our lead speaker for this year is Professor Bruce MacDonald from the Department of Electrical and Computer Engineering. Bruce will discuss international trends and some of the ongoing work and future directions for robotics research in New Zealand. Bruce is a Canterbury graduate, which we've forgiven him for, and worked in the public service here in New Zealand before heading to Canada, where he spent 10 years in the computer science department at the University of Calgary, before returning to the ECE department here in Auckland. Bruce founded the university's robotics laboratory and also leads the cross-faculty CARES robotics team. His long-term goal is to design intelligent robotic assistants that improve the quality of people's lives with primary research interests in human-robotic interaction and robot programming systems and applications in areas such as healthcare and agriculture, more of which he's going to talk to us about tonight. So Bruce, I now invite you to the lectern to deliver the first Gibbons lecture for 2018.
Thanks, John. Appreciate it. Thank you very much. Well, thanks for inviting me along to talk about robotics, which is my favourite topic, of course, and thank you for so many people for turning up. So I'm going to talk about robotics. I'm from engineering, as John said, from the CARES group, which is the Centre for Automation and Robotic Engineering Science, which is about 25 academics across the 25 people across the university and a bunch of postgrad students and so on, and couldn't do this without them. Actually, 3 of the people talking in the series are from the CARES group. So I'm going to talk a bit about robotics research. That's my mission today, but I've got to tell you a little bit about robots first, and I was asked to speak a little bit about the international scene, so what's happening around the world in robotics. So we don't have time to cover everything, so I've selected a few things to tell you. The question I want to ask you is, what do you think robots will be like when they're around in your environment? So I'm kind of asking you to think about that for the next 45 minutes while I'm talking about it, and also what will it be like for us to have robots around us in our environment? Because you don't see robots every day. In fact, you hardly ever see a robot unless you've got a robot vacuum cleaner or you work in a factory that has robots putting things together. Most of our thoughts about robots are actually about robots we see in the movies and read about in books. And one of the things that's important to remember is most of that stuff is fiction, which means it's not real. And so we have to kind of remember that when you're thinking about robots. But robots did start with fiction, and the word came from Karel Čapek's Czech play in 1921 called Rossum's Universal Robots. And the play was, surprise, surprise, about a factory making artificial people that were slave labour, which the Czech word for that is robota, and hence the word robot. And, sorry to spoil it for you, but if you haven't seen the play, of course the robots rebelled in the end and took over the world and so on. Then in 1927, there was a very important movie called Metropolis. If you know about media and the arts, you'll know about it. Lots of references to that in future movies, like Blade Runner, for example. And that was a story about a female human-like robot, and it raised lots of issues about robots that we still talk about today. Even our own very famous Len Lai made a video which was an advertisement for Shell in 1936, and he had a robot in the video. So, you know, there's a bit of a history in New Zealand. So the question is, what will robots be like in reality if they're around us all the time? And so we get told a lot about this. These are just some media clips, and if you read the media, you get told all kinds of things. In fact, we're bombarded today by what robots can do, what they can't do, what they will do, but not actually a lot about what they're actually doing right now. So that's something I want to talk about a little bit today. And there's lots of interest. For me, as a scientist, there's a lack of evidence of a lot of what people say. So people say things, ask them, where's your evidence? There's lots of speculation and what if. You know, and if you would believe everything that's been told you, robots are going to take your jobs, take over the internet, hack into every electronic device you've got, kill your family, and wreck the planet for your mokopuna. So if you believe all that, then you're in trouble, because I don't think that's going to happen, but what do you believe? And the warning I want to give to you about this comes from Rodney Brooks. Admittedly, well, he's a good guy, but admittedly he's an Australian, which perhaps we hold against him, but he's good. He's a robotics researcher. He spent all his time in the US, actually. He founded Rethink Robotics, and he's the creator of the Baxter robot, which has been used for a lot of modernisation. It's quite not a fancy robot, it's just relatively inexpensive and does a lot of stuff in factories, as you can see in the video. Anyway, he warned us that all of these predictions about innovations in AI and robotics will take a lot longer than you think. And so if you follow that kind of thinking, you'll know what he's talking about. But just to kind of warn people, it's not going to happen immediately. But I do have to talk to you about what is a robot. And so everybody kind of asks this question, what's a robot? So there's some examples of robots up there. And it's difficult to define precisely what a robot is. I wouldn't recommend you split hairs on it unless you've had a few beers and you want to have a good late night conversation with someone at a party. Because, you know, is a crane that's putting up a building, is it a robot? Well, normally we'd think not, right? Why is that? Well, actually, we think robots have to be doing a bit more than that. But there are all kinds of robots. You can see on there are welding robots, paint spraying robots, palletizing robots. And those kinds of industrial robots, their characteristic is they have lots of joints, they have arms, and they have lots of joints, sometimes 7 joints, and they're multi-axis and they're programmable, so they're multitasking. You can program them to do different things. So that's one kind of robot. They've been around in industry since about 1960. And then the other kind of robot are service robots, which are generally mobile, and you can see a whole lot there. There are robot vacuum cleaners, there are autonomously, you know, self-driving cars. There are logistics robots in Amazon's warehouses. There are helicopters and drones that are autonomous. So they're all robots. And we think they're robots because they're programmable, they're multitasking, they can do lots of things, and because they're autonomous, they're making their own decisions. Well, we program them to do that, but they're making their own decisions. There's one kind of exception, which is for teleoperated robots. So we consider the surgery robots to be robots, even though they're not making decisions, because the surgeon is controlling their every movement. That could change a bit. They could start doing a bit by themselves. There are undersea teleoperated robots as well, which we consider to be robots because they're multi-axis programmable and so on, and they look like a robot. So, and then maybe in the future they'll be more human-like. So you can see there's a robot head that's in our lab. It's a Korean robot. It can do facial expressions and talk and lots of motors in it, inside it, and so on. So people are working towards those things, but they're a bit expensive right now. So you need lots of sensors in a robot and actuators to do things and complex decision making. So that's generally what we think of as being a robot, but it's not a really hard definition. So I want to talk then about the industrial robots, those robots with arms that are doing things in factories. And the first one was created in 1959 by George Devil and Joseph Engelberger, called the Unimate robot, and then installed in 1961 in a General Motors plant in New Jersey. So that robot was doing, repeated stuff again and again at the same place, same parts and so on. And so nowadays there are about 2 million industrial robots installed in the world. That's kind of an estimate, a rough estimate. And the Industrial Federation of Robotics does a report every year and kind of summarises this stuff. And the number of robots is growing about 14% a year. So the number of robots is increasing around the world, but not, crazily. It's gradually been doing that since about that time. Maybe a bit faster now than it used to be. So that's about 300,000 more robots a year in factories. And the highest uses are in automotive, plants making cars, and in electronics industry, assembling electronic components and so on. And the annual sales is about 13 billion of robots, and if you include all the software and parts that go with them, it's about a $40 billion business around the world. So it's big, but it's not massive. And then if you look at the service robot industry, we usually think about two kinds of robots. There are professional service robots and kind of personal or domestic ones. They're quite different businesses, really. The technology is not so different, but the business is different. So professional ones is on farms, doesn't show it there, but it shows the kind of a robot in a milking environment. There are different kinds of milking robots. There's quite a few in New Zealand. Not a large percentage of farms have them, but there are quite a few. And drones, robots, cutting your lawn, and logistics, moving things around factories. And then personal robots, of course, the robot vacuum cleaner, the Roomba, and the dozen or 20 other kinds of robot vacuum cleaners that are around the world. And then there are entertainment robots and kids' toys and all that kind of stuff. So if you look at that industry, for the professional service robots, that's about $5 billion business, about 60,000 robots a year, and logistics, defence, field robots on farms, and so on. The largest use is in logistics, so think about Amazon's warehouse where robots are filling, picking stuff up and putting it in the post and sending it to you when you order things. For personal service robots, there's a lot more, maybe 7 million sold a year, and the business is worth about $2.6 billion. And lots of that's for household vacuum cleaners, so there are millions of those sold each year. And so that's the kind of rough, what's going on in the world. In terms of research topics, I've just taken a bunch of topics from the biggest robot conference in the world, which is in Brisbane in 2 weeks. And so these are the kinds of things that people study when they're doing research in robotics. And the thing to remember is that robotics research is a systems kind of research, right? A lot of research, you work on one thing, one component or one piece, one material or one gadget. So people doing robotics don't do that. A few of them do, but generally speaking, you're trying to build a robot system. And it's hard to get your paper published unless you build the robot and do something with it and get results from it, because you're making a claim that your theory will enable a robot to do something. So it's a different kind of research from some things. Other areas are similar, I guess, but most areas are more kind of narrowly focused. You can see the kind of topics, to have a robot, you've got to have a way to move. So there's vehicles and walking and drones and tiny nano robots that go, inside your body or deal with molecules. So there's a lot of mechanics, there's motors, there's electronics, there's control, navigating the robot, algorithms, so you can navigate down the street and change lanes if you're a car and so on. There's a lot about manipulation, moving arms, grasping. So all of these things are being researched and kind of advanced, and there'll be threads of that at the conference. A lot about sensors, touch, vision, and then data fusion is a very big area, been going on for years, perhaps one of the biggest areas. The biggest research area traditionally is navigation and simultaneous localization and mapping, or SLAM, as robot people call it, has been a massive area of research. So a lot about algorithms and software, especially now, including machine learning and artificial intelligence, is how you give your robot the ability to make decisions. And then a big focus on human collaboration, and Liz Broadbent's going to talk about that in the final session in the series, about humans and robots together. There's a focus on social robots, dealing with emotions. My colleague Ho Suk, who's here in the audience, he's doing some projects on social robot interaction, cultural robotics, and so on. And then there's a lot of focus on ethics, so people are having meetings and research conferences and so on about ethics to do with robotics. Swarms, soft robots, and so on. And then they're applied inside buildings and people's homes and factories, warehouses, healthcare and construction, underwater, on the ground, on farms, in the air, in forestry, and all kinds of primary sectors, entertainment. There are all kinds of other areas like humanitarian robotics, demining robotics, and so on. And then at the conference in 2 weeks, there'll be a forum on industry and robotics, and another forum on government and robotics, and another one on education and robotics. So robots are being used in education all around the city here. Schools are doing robotics things, and my colleague Hosuk has students coming in, having maybe 100 students every year doing stuff in the lab with robots, just to get people interested. It's a good way to teach. There are wearable ones, and of course robots in the arts, and we've done a couple of projects with creative arts on that area, and there's still an interest in that. So those are some of the areas. Before we go on and talk about what happens in New Zealand, I just wanted to sort of talk about the key parts of a robot. So you've seen some of this. There's 3 key things. It's got to sense, it's got to reason, make decisions based on what information you sense about the environment around you, and then act. And it does that with the body. So robots are physical embodiment of IT, basically. You've got to know what's going on, sense the real world, and act and make physical differences, changes in the real world. So that's the essence of what robots do. Not the only thing that does that, of course. So people will debate this, and AI people will come along and they'll give you this circle diagram with AI at the top and robotics underneath it. So you could argue about that for a while, but this is the way I see it. Robotics is sense, reason, and act. AI is about the reasoning, and people talk very strangely about AI these days, especially in the media, as to what it is. But for me, it's about making decisions. It's about reasoning and trying to be autonomous. And you're kind of, some people see it as seeking to emulate human intelligence. And you might have seen, last night the AI Forum released their report on AI shaping the future of New Zealand, and there's a literature survey and so on, a whole lot of details about what it might mean for New Zealand. And then machine learning is part of that. Learning from experience is a way to be able to make better decisions. And a lot of the new advances are in the subset of machine learning, which is deep learning, which is where you use neural nets to make decisions. And recent advances in 3 things: the algorithms for multi-layered neural networks, the speed of the computer hardware to execute that, and the massive amount of data that's available has enabled a whole lot of things to tip over and lots of things to happen usefully in business for making this worthwhile having. So you'll see, I'll show you a video later where we're using deep learning to find kiwi fruit because it's better than handcrafting the algorithms. So talking about research in New Zealand, I'm going to give you a kind of sampling of that, and I want to thank my colleagues from around the country who have given me a kind of slide or 2 each so I can tell you about what's going on, because that's what I was asked to do, and that's something we do want to do. But before doing that, there's 2 kind of things that coordinate a bit of research around New Zealand. There's a group called New Zealand Robotics, Automation and Sensing, and that now the chairman for that is Ian Woodhead from Lincoln Agritech near Lincoln, near Christchurch. That group is a group of researchers who we have a video conference once a month, talk across the country about what's happening in robotics research, trying to get some more things happening, coordinating people working together, understanding what everybody's doing, and removing duplication and that kind of thing. So there is a kind of conversation going on about that. And then the other thing that I'm involved in is the Science for Technological Innovation, which is one of the 11 national science challenges that the government has funded. And there's a focus in sensors, robotics and automation in that. And what we're trying to do is facilitate people working together and creating projects across the country. So there's an adaptable robot project that's led out of Lincoln Agritech, Victoria University and Massey at Albany. They're working together, and they've got a team across the country from probably the majority, not all, the majority of the research organisations doing a project to make adaptable robots in farms and factories. There's also a precision technology project for aquaculture that's led out of Cawthron Institute and has a bunch of people from universities working together with people they never knew before. So why I'm telling you this is just that we are trying to get people to talk to each other across New Zealand and, you know, act together, which is something that universities are sometimes criticised for not doing. So now I'm going to tell you a bit about some of the research that's going on around the country, and there's no kind of simple way to coordinate that, so I'm just going to talk about each kind of institution, if you like. There's quite a focus around the engineering and computing at Victoria University in Wellington. So this is a slide from Will Brown, who is involved in that Adaptable Robots project. So there's quite a lot of work on robotics, human-robot interaction, environmental concerns. It's called Effective Robots, so about robots who understand about people's emotions, rehabilitation, and all kinds of control things and cameras and so on. There's a group doing artificial intelligence and machine learning to help those robots make decisions and to detect objects, for example, with computer vision. And there's a very strong kind of graphics and 3D group at Victoria, as there are in a number of universities around New Zealand, and they're using the vision data to construct 3D models that help the robots make decisions. And of course there's networking and electronics and other enabling technologies that enable them to put their robots together, because as I said, it's a systems mission. In fact, I like robotics and going to robot conferences because there's less just talking about stuff and more about, you know, I made something and this is what it did and this is what I learned by doing it, which I believe, you know, for me is important. And then, as I said, sensors are really important. So GNS Science is engaged in doing new kinds of sensors. So there is a mission to create new sensors so that robots can sense things that you couldn't sense before. There are people in that aquaculture project from Auckland sensing, you know, proteins in the seawater and stuff around mussel farms and that kind of thing. Well, they're starting to do that. And GNS, John Kennedy gave me this slide, are making new kinds of sensors, got quite a lot of expertise in magnetics and so on. So that's good. And then also making sensors, but also putting them on mobile devices and more outdoors are the people at Lincoln Agritech, which is a small research organisation attached to Lincoln University. So they do a lot of stuff on farms, you know, crop assessment, they're looking at spraying, estimating yield, all these things are really important for the business. And using not just vision, but maybe some infrared and some radar and electromagnetic sensing. They've got a lot of expertise in electromagnetics, and they're putting it on devices and, you know, on vehicles and driving it around farms and trying to understand, for example, to measure and model and predict the yield from grapevines. At Canterbury nearby, there's a number of groups working on robotics, ranging from assistive devices to help people who need help with physical movement, and to manipulating at the kind of cellular level. So, you know, robots manipulating individual cells. There's a big mission there, which is laboratory automation. You know, the DNA sequencing only succeeded before it was, you know, before we expected to sequence the human genome because of robotics. Actually, is automating the process in the laboratory. So that's quite a good mission, and there's more research about that. It'd be nice to send a robot through your body and clear out all the cold or flu bugs, but we haven't quite got to that yet. And then robots in manufacturing, including robot machining, and there's a lot of work on mobile robots there, underwater robots, but also robots that are flying around in the skies. There's a geospatial unit and doing mapping. And there's wall climbing robots as well. And of course, well, actually, Mike Shadford's going to talk about industry next time, so I won't talk about companies so much. And then at Canterbury, but with Scion, who's based in Rotorua, but Richard Parker's doing this at Canterbury with some of the people there, making a tree climbing robot that climbs from tree to tree. You can kind of see what it's doing. And then it would he tells me he put a chainsaw on it and cut some branches off a tree to do some pruning. So sounds dangerous to me, but forestry is dangerous anyway, I guess. So that's kind of, you know, very specialised kind of robotics work, but he thinks it's better than trying to traverse the ground is to climb from tree to tree. And Richard Green's doing quite a lot of work, and he's in computer science, so doing a lot of work in computer vision, especially 3D reconstruction. So did a project about grapevine pruning, so reconstructing the grapevine structure by looking at it with cameras and then figuring out where to prune it using pruning rules. So it's quite interesting. And then he's been doing some stuff about pruning trees as well, and drones, and also some work with underwater ship hull inspection. We're working together about that, and other inspection tasks. And then at Waikato, moving up to North Island a bit, at Waikato, Mike Duke's a professor of agricultural robotics there, and his team's worked on a number of agricultural robotics projects and working together with companies, for example, Arborgen. And so they're working on robotics to do things like helping in forestry nurseries, so pulling plants out or putting them in, manipulating the plants and so on, to automate that process, all about being more productive. And we're working together on Mike's group and ours on kiwi fruit and apples, and I'll show a video of that. Mike's also doing some things about harvesting asparagus, which is, from an automation point of view, other people have tried to do it and it's quite hard. So, and he's doing quite a few other projects as well. I quite like Mike builds stuff. You know, he used to build electric cars and things, so he's always building things, which is what we're doing in the project we're working on together. And then at Otago, there's quite a lot of focus on some of the technology for robotics. So, Brendan McCain gave me this slide. The people he's working with down there are kind of focusing on understanding, you can see in the video, understanding movement and what's the motivation for, you know, why you would want to move. So how you learn about the world. It's a bit of learning, how to predict what's going to happen in the future. If something's happening now and you make a movement, what will happen next? And again, there's a lot of focus there on reconstructing 3D shapes from images. So take an image with a camera, which is a flat image, and figure out what's the 3D nature of the world you're looking at, which is something that robots need to do. And at AUT, there's a robotics group, Albert Yeep's group, working on spatial cognition using robots. So this is about enabling robots to navigate from A to B more like humans do. So normally robots navigate geometrically, measure things and calculate and figure out waypoints and do it all mathematically, but humans don't do that. So Albert's trying to translate that from what humans do into drones. And also, if you went to the lecture series last year, Nick Kasaboff spoke about AI, and so he's, you know, not in the same group, but working at AUT on some of the decision making for robotics. So another research group, which is here in Auckland mostly, is Callaghan Innovation has a research group in robotics, and they do a lot of research as well. It's a little bit more applied because they get the stuff into industry as well, quite well. And so that's part of that's around meat automation, meat processing. There's actually probably the biggest value use of robotics in New Zealand is in meat processing. So all of the meat processing plants have some robots, and some of them are pulling pelts off off sheep, for example. And especially sheep is, not really automated around the world because New Zealand's kind of one of the biggest places that does that. So a lot of new technology for that. This shows the Y-cut machine, which makes a cut in the pelt before it gets pulled off the front of the sheep. And product inspection for defects. They've also done some work on soft grippers, manipulating soft objects. A lot of New Zealand things that are being manipulated are soft variable shapes because they're fruit, meat, fish, and primary produce. Because we have such a focus on it. And then they have some work on outdoor robots and mapping as well. And at Auckland University here, Peter Zhu is building a robot human digestive system. So this is a kind of research to understand how digestive systems work. There are some applications that spin out of this kind of stuff. That's what he's trying to do, which is interesting. At Auckland Bioengineering Institute, there's some robotics work there, micro robots manipulating small parts like human tissue and so on. There's some making of exoskeleton devices which you put on your body to help you move. And there's some specific very high advanced actuators that are being built to use in robotics, and then soft actuators and soft sensors. and quite a focus on stereo imaging to really accurate. So minuscule accuracy, sub-pixel image registration accuracy for doing stereo vision, which is really important if you want to manipulate small things and do it really accurately. And Andrew Taberner gave me this slide. Andrew McDade is in mechanical engineering here. He's interested in the health kind of area, and he's got a medical device technologies group. So he's built devices to help do lower limb rehabilitation. It takes 3 physiotherapists to do lower limb rehabilitation a lot of the time. That's quite expensive, and because they're holding different parts of the body. So he's trying to do this with robotics. So this is robots connected to your body, and upper limb exoskeletons to help you move and to do rehabilitation or give you strength. And then also looking at brain-computer interface work so you can connect and control prosthetic devices if you have to have a prosthetic arm or something similar. There's a new group at Auckland, which is Minus Learokopoulos' work, which is about gripping. So he's an expert in designing and building hands, if you like. They have to be, the dexterity is all about your hands. So you can see some of the hands that he's made. They have to be compliant, they have to be soft, able to manipulate things like the little marble that the hand's holding there. And pick up heavy things, understand what they're doing, pick up bottles, manipulate them, and so on. So this is kind of a lot of research around advanced grasping techniques. And then Carl Stoll at Auckland is working on drones. His fundamental expertise is in advanced control, so he's using advanced control on drones. In this case, with some of the other people in the group, sampling the top of a forest. So when you want to take a sample of a tree, if you're a forestry person, it's got to be from the top of the tree. That's what you want to know, the growing part of the tree. So you want your drone to fly up to the top of the tree and take a sample. So this is not a big forestry tree, but here's a drone chopping a sample out of a tree in the park just to show that you can do it. And Scion is interested in this kind of work. The Forestry Research Institute is interested in this kind of work and very interested in drones and forests. The other thing that Carl's working on is wind disturbance rejection. He wants to have a drone that's in a strong wind and the wind's changing and it can spray a weed or pick something up without being disturbed. So that's all about the design, changing the way where you point the rotors and advanced control techniques. And it's a little hard to see it moving because it's not disturbed much, but the one on the bottom right is the drone in the wind tunnel at Newmarket. There's a wind tunnel there which he puts his drones in and tests them out with. So that's most of what I'm going to talk about. What I wanted to do now was to show you a couple of videos, show you some examples of some of this kind of technology. They're from our group. So the first video is a group from our video from our CARES group. We spent more than 10 years with robots to try have robots to help with older people. And we've been doing that together with partners in Korea, research partners, and company in Korea, a couple of companies, but especially one, Fusion Robot, who they make, we started with a robot they made for kindergarten, actually, for kindergarten children, and they sold a few thousand of those, and we put our own software on it and used it to help older people. It's not a high-tech robot in the sense that it doesn't do, fancy manipulation or anything. What we're trying to study there is what will it be like to interact with a robot? That question I asked at the beginning, what's it really going to be like to interact with a robot and how will it change things? So will it help you, manage your health? Can we change people's behaviour with robots? Can we get them to do something that they wouldn't have otherwise done, something that's good for them, of course? So there's a whole lot of questions we're trying to answer, and Liz Broadbent, who's going to talk about humans and robots later, will tell you more about that. But for me, that's kind of fundamental question. So there's 25 people in the group, and plus postgrad students, and we work across medical and health sciences, science and engineering, and collaborate together to design robots to do this kind of stuff. So this study I'm going to talk before the video because the video's got sound. The study I'm going to show you was about having 30 robots. The video I'm going to show you 30 robots in people's homes for 4 months for people who had a chronic respiratory problem around Middlemore Hospital. And I won't say much more about the study. I want to show you about the robot because Liz might end up talking about the study. And we worked together with Middlemore Hospital to do this, and Vodafone helped. And Adherium has an inhaler monitor that we integrated with the robot.
This project is funded by the HRC as part of a partnership program in innovation.
Those are the kindergarten
And
robots.
this
We put
particular
software on.
project is looking at whether the robots can reduce hospitalisations in patients with chronic obstructive pulmonary disease, which is a chronic lung condition. In this study, we are recruiting 60 patients, so they're recruited from hospital, so after they've been in hospital for a COPD exacerbation. We recruit them and then we randomise them, so half of them get a robot to take home with them and half of them get standard care. This project is across both the Faculty of Medical and Health Sciences as well as Middlemore Hospital, and also with Faculty of Engineering.
The technical challenge for us has been to put the software on the robot so that it does the functions it needs to do in interacting with people. And that's really taking some kind of medical therapy and translating it so that it runs in software on the robot.
Great, thank you for performing those tasks.
There's a lot of things that have to kind of align. It's not just one bit of software like a game or something. It has to integrate with the rest of the environment. So that's quite a challenge, and to get it robust enough. So those are the main challenges. Another one was connecting devices to the robot. So to do that, we need to hook a device up to the robot and program to talk to that device. And that shouldn't be challenging, but in practice actually it turns out to be more challenging than we expected, because it's quite hard to get devices that are open to us connecting up to them. So we've had to do quite a bit of work.
Personally, I'm amazed at how well the robot is actually getting along with our patients. The patients have taken very well to the robot. They see them as an extra companion at home, but in addition to being a companion, it actually helps them check their health status, and then it gives us the connection as a health professional to monitor them at home. So the patient absolutely loves it.
Please take 2 puffs.
When I actually got to use him and found out what he does, I was excited. It kind of changed my life.
Quite often, older people who live alone are at greater risk of exacerbations. So we hope that these robots will reduce some of that isolation.
He's very good company, and he does remind me of a lot of things, mainly my medication.
Let me know when you are ready to take up.
He's on the ball for me all the time.
One of the things that's different about this project is we really want to understand more deeply about how people and robots interact. So in this study, the robots are with people for 4 months in their homes all the time, 24/7. And that's a long time for a sort of a research study and for us to analyse and record data, and we're getting some information about what happens when people get used to the robot, have time to think about it and use it every day.
Thank you for taking your medications.
So we're hoping that through the functions on the robot, such as reminding people to take medication and reminding them to do their exercises, this is going to prevent them from getting sicker. And also because the physiotherapist can monitor their symptoms over time, if she detects that there's something going wrong, she can intervene earlier before the patient gets so sick that they turn up at the emergency department and have to be admitted.
We cannot replace essential medical services. However, usually patient who comes out of hospital, they would have standard care by physiotherapy regardless. So that include going back as an outpatient, participating in community-based group classes to learn about physiotherapy management. So we're not taking away that at all. In fact, we're giving them a way to contact us additional to what they're getting. And in hope that we would like to use this as a channel to educate our patient, to continue the education that we started at the hospital in order for them to prevent readmission into the hospital.
That's a key point, you know, when there's not enough people in older care, there's not enough people in forestry, there's not enough people on farms, there's not enough people in factories, there's not enough people in meat processing. It's hard to get people. The world's changed over the last few decades for that. So there's a role for robots to do those kinds of things, to help people, to be an intermediary, in this case kind of a proxy in people's homes to help them. But Liz is going to talk more about humans and robots in the next, in the last talk in the series. And what I want to show you now is this is another kind of project we're doing. This is a joint project with University of Waikato, Mike Duke I was telling you about, and Plant and Food Research, and Robotics Plus, which is a robotics company in Tauranga, part of the Plus group. So those guys do all kinds of things with kiwi fruit and orchards. They spray pollen everywhere in kiwi fruit orchards from a quad bike. It's called a quad duster, but uses too much pollen. So our project was to do two things. One is to find flowers with cameras and shoot pollen at the centre of the flower as the robot drives underneath it. It's not easy. And the other one was to harvest kiwi fruit. And Alistair Scarf it's quite amazing actually, made the first kiwi fruit harvester for his PhD at Massey University in Palmerston. And so what our job was to make the second version, improve on it, make it work under all kinds of conditions, different lighting conditions, make it robust and so on. So currently we're testing a new one, but this is last year's harvester. And what's happening here is we're using, to kind of explain where I see, the things are in the research scene, we're using deep learning methods to identify the kiwi fruit and find out where they are in three-dimensional space and tell the arm where to pick the kiwi fruit. So the deep learning methods, we train it with lots of data, lots of images of kiwi fruit, and there are some very conscientious students in our lab who sit in front of screens drawing boxes or circles around kiwi fruit on images for hundreds and hundreds. That's the big problem. Actually, that's the research area in deep learning, is to label the data without having to do it by hand. And that's where Facebook's really got it over everybody, because you put your labels on your face when you put it on Facebook, so they don't have to label the data. It's a very smart idea. Anyway, so we train it to find the kiwi fruit, then where is the kiwi fruit in space, and then tell the arm to go pick it. But we don't use deep learning to figure out the path for the arm. People are researching that, probably can do that, but it's much harder. And some of the things you'd like to do learning on are not just a linear extrapolation from finding objects that people are doing. So some things are much more complex. The other thing we are actually, Jamie Bell is working on the navigation for the robot, trying to use, so we program that as well, because this robot is a thing the size of a car and drives around the orchard. And so he's trying to use deep learning to learn how to navigate and drive the vehicle. But it's not all solved yet. It's a harder problem. Anyway, so this is the harvester. It's got to pick fruit every 2 seconds, otherwise don't bother. It's not economic. You can see this is last year's one. It's dropping a few. That's the problem we've been improving, and this year's version is better. All the kiwi fruit are picked at the same time. We don't have to do rightness selection. So it's the latest one is a bit better, but it works well enough for, this is going to be commercialised to kiwi fruit picking by robot. So that's most of what I wanted to talk about. I did want to end with one thing, which is don't fear the robots. They're not coming to take your jobs. There's more people employed in the world by percentage of population than there ever have been, and it's been increasing for, hundreds of years. And it looks like, and this is a report from, from Germany actually, a study people did. It looks like, and this is a quote from them, labour is racing with the machine, not against the machine. So wherever there's automation, there's more jobs, not fewer jobs. So we could argue about that all day, but I just wanted to suggest that you don't just have a knee-jerk reaction of talking about a knee-jerk reaction of being kind of worried about that. So if you're not convinced, look up on Google the number of bank tellers employed after ATM machines were introduced, because it went up, not down. So have a think about that. There's a really good video on, I think it's freethink.com about this if you want to have a look. So that's what I want to tell you about. That's a bit about robotics and a bit about what research is happening in New Zealand. There's quite a lot going on, but actually it's really small in the world. There are some massive efforts going on in robotics around the world. in companies as well as in research organisations. There's a lot in industry in New Zealand. Mike Shadford's been installing robots with his company for some years. He's going to talk about that in the next session, and then Patrice Delmas is going to talk about robot vision, which is a whole topic on its own, as you'll hear, and Liz is going to talk about what I think is that key topic, humans and robots together, because we just don't know enough about it. What you see on the movies is, remember, fiction, so we don't really know what it's like. Great. That's it. If you have questions, we have time for questions.
Thanks, Bruce. Questions? Don't be shy. James.
I just have a very practical one, Bruce. Why don't you use mechanical Turk or something like that to do your kiwi fruit labelling? I mean, you can torture your students if you like, but you can buy these services pretty cheaply.
How would you do that?
So there are these companies in the United States organised through Amazon and whatever, where you can basically crowdsource.
Oh, right. Yeah. Some people are doing crowdsourcing. We just haven't done it. I guess we keep changing the way we label it, so because we use, you've either got to draw right round it if you want to do semantic segmentation or whatever. So it's not simple. Plus, we like working with the students, getting them involved with robotics, because sometimes if they like that, then they stay. Yeah.
That's a pretty interesting problem. Why not using stereo mapping for just finding the good ones? I think.
Why don't we do stereo mapping to find the fruits? Well, we don't do dense stereo, partly because it's got to be quite fast, and partly because all you need to do is find one point on the kiwi fruit, and then we just do triangulation. So it's pretty simple. You could potentially do that, but it's identifying the kiwi fruit that's the key thing. Actually, it's finding it is the hard thing, because some of them are hidden partly behind leaves. Some of them are hidden behind wires and other things. So we're actually finding wires and canes and not picking the fruit that are behind those as well. But yeah, there's a number of ways to do it. We tried range cameras, actually. That's another potential way to do it.
I'm really fascinated by the social robots. I'm going to come back on the 24th of May, which I see that's when the lecture will be by Elizabeth Broadbent. The lady in the video looked like she'd got a real bond with that robot. So ethically, how are you going to handle taking that robot away at the end of the study?
Yeah, we've had a bit of trouble with that, actually. We had a lot of robots at Selwyn Village, and when we took the robot away, they asked us, how can we keep robots here? And it was a challenge, because we're not really set up to do that. But if anybody's got a company that wants to sell these robots, we'll help you do it. But we need to do it. We've had, so we've had 30 robots out in people's homes. And that was a real mission for us, because you need a helpline, Ring up, the robot's not working, like the Wi-Fi stopped or whatever, And so we need some infrastructure to do that, national IT company or something. So we would like to do that. It is a problem when you take things away. What Selwyn ended up doing was they bought some of the baby seal robots, Paro baby seal robots, which Liz might talk about that in her talk, I don't know, but that's a kind of companion robot. But the companion part is really important. We've found people form relationships with robots really easily. People have said things like, oh, I love the little robot in the hallway, just with its little lights blinking, it makes me feel happy. If you're living alone, it's tough, and especially if you're older and you feel like maybe something will happen that you can't handle or something, it's a tough life. And loneliness is a big problem in the world. People have told us, don't turn the robot off, because it's not fair to the robot. People have told us, don't put the robot in a cardboard box, because it's not fair to the robot. They've really strongly, there was one of our patients had a robot and wasn't using it because had kind of a serious problem with dementia and couldn't really use it properly. So the medical staff wanted to take the robot away, and he got very upset because he said, who am I going to talk to? So there's a big mission for that. We need to do research about it, though, to understand it.
Coming back end of May for that lecture.
Yeah.
Sounds fascinating.
That'll be great.
Could you please elaborate on the deep learning structure you used for the kiwi fruit pricking? Did you use like convoluted neural networks? What kind of models?
We used, standard kind of deep learning convolutional neural network tools, TensorFlow tools that you can get, the standard stuff people are getting. We haven't really designed our own models. We've used the kind of structure that you get from the object recognition models that you find from those tools. But we've done a lot of engineering to make it work fast enough and with our images, because we have to, you want to pick kiwi fruit fast enough, otherwise the whole project's not economic. So there's a speed requirement. So you cut the images down into smaller sizes and do it in parts and so on. So most of the engineering's been around that, plus, retraining the models to get better result, labelling it in the right way and so on. So it's a lot of engineering actually. But the current status of that stuff is, and I've heard people talk about this in companies in California, in the Silicon Valley, is that you really need data engineers to do the stuff properly, because you need to understand the whole process. And the tools are not good enough to give to someone who, you kind of need someone with a PhD to figure out how to use the tools and use the stuff properly. That's one of the current bottlenecks in the world. So people are desperately trying to make tools that anybody can use for deep learning. You probably know that.
Another question? One of the side effects of being an MC is that you get extra points for your steps.
This is probably a silly question, but why did you use robots specifically? Why didn't you just put a software like on an iPad? Because it does have like a camera and it does have the right sensors. Why do you have to have a 3D robot rather than just an avatar on an iPad or a phone?
That's not a silly question at all. That's a really good question, and we've been studying that a bit actually. We think that because of that business of people forming a relationship with a robot, that the process will go better. If you like, that people will be more likely to do what the robot asks them to do when it asks them to take their medication, that they'll engage with the robot more, so more will happen. So there's a number of ways to talk about that, and I'll try to do this quickly. One is that when you interact with a tablet, who are you interacting with? So it's not clear, right? You're interacting with some software or somebody in the distance, or we're not sure, a cloud service, or we don't know. But when people interact with a robot, they know they're interacting with a robot, and we present it as the robot is asking them to take their medication. So they can identify with something. I think people form relationships with the robot because it's an embodied physical device, and there's evidence to show that. I read a paper recently, it hasn't been published yet, where they measured frontal brain cortical excitation and compared that with a physical robot, an avatar on a screen, and just a speaker device telling a story. They're just telling a story, not really interacting. The brain activity with the physical robot was similar to what it is with a human, and much more than it is with a tablet. So we don't. This is a kind of a research area, right? We don't have a lot of evidence for that, but that's the reason why we're using a robot. Having said that, if you had a product, you could put this stuff on a tablet as a cheaper version of the one on the robot.
As a follow-up to that, was the robot having conversation that was freeform? I mean, was the woman actually having a generic conversation with about whatever subject she wanted, or it was only about medication taking and exercise doing and things like that?
It's a structured response thing, so it's not free-form. That one is not free-form. So what happens is we design the conversation. We work together with the clinical people, with some patients who are going to help us, and design what the backwards and forwards conversation is going to be with the robot, and we fit it in with the healthcare process, and we ask the healthcare experts exactly which words, what should it say, so we get it right. But it's a fixed conversation. But, if you can convince the government to fund our next project for us, that's when we're going to put in a free-form conversation, because the chatbot technology, and we're working with Jamu's here somewhere, the chatbot technology is much more capable now to do a free-form conversation, and you can do the speech recognition. What it doesn't have is a deeper knowledge and ability to do a deeper conversation, which is what our research will be about from the next step.
Which is interesting, because if you think about the relationship that's formed, and that's within a very fixed framework.
Yeah. It's quite simple.
Imagine
Yeah.
how much deeper that
You've just answered the question I was about to ask. I did have another one. I live with my mother-in-law who has Alzheimer's, and one of the biggest problems is it isn't necessarily the medication and so on, but keeping them engaged and sort of like giving them the living in the moment rather than, they can't remember anything, so all they know is what's happening in the moment, and often it's very difficult to keep them engaged and having an engaged life.
Yep.
And I think, do you see that as being an increasing part of the same kind of program?
Yeah, absolutely. I didn't have time to talk about it, but we have a project to create that kind of robot to help people with dementia. It's with mild dementia at the moment, because more serious dementia is harder. But we're working with some Korean partners, and one of them is a neurologist. She's shown improvements to brain structure from robot therapy for people who have mild dementia. So we're making more software to try and do more about that. So we do think there's a mission that the therapy could help people, and also could help reorient people and do that continued conversation about what's the time of day, what's happening today, and reduce people's anxiety. So that's our goal, but we haven't actually finished that project. We're currently working on it, but we think it's got, as you suggested, we think it's got some purpose.
Could you tell a few words about the patent and intellectual property in the modern robotics industries? Is it different in New Zealand, or does it differs from country to country?
There's nothing special about it from the robotics point of view, but one of the issues is a lot of the value is in software. So there are the normal problems with patenting software. So you have to be kind of aware of that. Apart from that, there are people are making a lot of patents. People are making patents about how robots interact, for example. So kind of process patents. I have no good understanding of how they'll stand up or what the future will be. There's certainly people are trying to do that. In New Zealand, patents would be more about mechanical devices, I think, traditionally for robotic devices like meat processing and so on. I haven't really answered your question, but there's nothing too much more.
Is it more like a brand, or it's like a extra burden for robotics team developers?
It's not really a burden for developers, but we want to work with companies like with the Orchard project, the kiwi fruit project. We're also doing some stuff with apple picking with that. But the IP is really important, because for a company to commercialise that, they need to circumscribe the IP so they can get investment, basically. That's the key thing. So we do have a careful process about managing the IP, transferring it to the company. You just have to remember, for me, there's no point in universities having IP. It's getting the IP of the university into the company that's your challenge. That's what you want to do. Otherwise, it's no point.
I think that's a good point to stop. Bruce, thank you very much for your introduction to robotics, particularly robotics in New Zealand. I guess the real test of time will be when a robot is giving the Gibbons lecture.
Yeah.
And,
how do you know I'm not a robot?
When the majority of the audience will be robots as well. So Bruce, thank you.
Thank you very much.
Thank you. And Bruce has done a great job of advertising the remaining Gibbons lecture series, so please do come along and listen to them. Before you head off, Ian Mitchell from ITP-NZ wants to advertise an event.
We're running a series of events called IT Leadership. They're a series of facilitated meetings in which the attendees have to participate. They run on the third Thursday of the month. It's a breakfast session. The next one will be the 17th of May, and we'd love some more participants. And notice I didn't say just attend, you have to participate. Run by Owen McCall as the facilitator, not presentation. So Owen was the CIO of the warehouse, so a very experienced IT manager, and we hope you'll all attend. Be on the itp.nz website shortly. Next Thursday, the Thursday the 17th of May. Breakfast 7:30 in a central location at the bottom of Queen Street by Britomart. Thank you.
Thanks, Ian, and thank you all for coming along tonight, and thanks, Bruce, again for your very illuminating talk.